or what we know is, we know it's 20 feet. And we know the 14.1 minus 12.5 is 1.6 feet. Right? So what you did is 14.1 minus 12.5 is 1.6. Okay? So now, if you do 1.6 divided by 20, 0.08 or 8%. So this slope here, and again I'll do it in pencil because you don't want to keep it here, is 8% from here to there. What I tend to do is then I figure out all of my slopes. It's this fast math, it goes pretty quick. So I want to do the slope between 12.3 and 11.4. So 12.3 minus 11.4 is 0.9. And it's 20 feet. Once you have your calculator set up for 20 feet, I just don't change my equation in my calculator, I just change the 0.9 divided by 20, and that's going to be equal to 1 point something, huh?
0.045.
0.045 or 4.5%. Okay. Whenever I do a slope, I always put the arrow in there going downhill so it helps me remember what's going on. It's only for my benefit.
Where did the 20 come from?
It's 20 feet from here to here, here to here, here to here. We have our spots is exactly 20 feet. Okay? Yeah? Okay? You can always measure it, but we know if you drew it right, it's measured right. Okay? So now from here to here, 11.4 minus 10.3, we want to figure out the slope. 11.4 minus 10.3 is 1.1 divided by 20 is what kind of percent slope?
0.055.
So 5.5? 5.5%. Okay, we have another slope in here, 11.7 minus 10.3, so that is 1.4. 1.4 comes from 11.7 minus 10.3 divided by 20 feet.
7%.
Exactly?
0.07, yes.
Wow, that's awesome. Very seldom we get round numbers. You also need to know it from here to here. So 12.3 minus 11.7, did we do it yet? No, we haven't.
0.6.
What is that?
0.6.
So 6%. This is exactly the same, so this is also 6%. Okay, so find the cheat points. If you know that this is exactly 20 feet and it's 12.3 minus 11.3, so 12.3 minus 11.7, sorry, is 0.6. What?
I think it's 3%.
6
Yeah,
divided by
we
20.
do, so that was just.
It is 3%.
Oh, it's 3%, sorry.
Yeah.
3%, so 0.6 divided by 20 is 3%, 3% here.
Yeah.
Because it's 0.6 divided by 20 for that equation. And if it's that here, it's always the same over here. Because it's the same numbers, the same distance. There's only two left. 13.5, am I going too fast for anyone? 13.5 minus 12.3 is 1.2. Divided by 20.
6%.
Is 6%. And the last one over here, 14.1 minus 13.5 is 0.6 divided by 20, which is the same as over here, so it's 3%.
What about the from 12.5 to 12.3 up top?
If you want to do that,
No,
It's on the middle.
this one?
Yeah.
Okay, we can figure out the percentage, but there's no number in there, so you don't have to.
You don't have to.
You don't have to. Well, let's do it just because. because you're asking about it. So it's 0.2 divided by 20 is equal to 1% slope. It's kind of scary that I can do the math usually pretty quickly in my head because you've done it, because I've been doing it for so many years. You'll get there. It's going to take time. That's why it's better to have a calculator and not your phone for a calculator, because the calculator is a lot faster because your phone's going to keep turning off between every time you put in numbers. Okay? Just a suggestion. Okay, so now that we have our percent, what we need to do is we got to figure out where 14 is and 13. So, if we want to figure out where 14 and 13 is, we know the slope now is equal to 8%. We know the run is equal to, we know the rise. We can, because we're going to figure that out, we don't know the run. Run is x. If we're going 14.1 to 14, because we want to find 14, 14.1 minus 14 is 0.1, is the rise. Okay, so we got to figure out how far that is. So it's 0.08 is equal to 0.1 divided by x. You're going to times x on both sides. You get 0.08 is equal, x is equal to 0.1. X is equal to 0.1 divided by 0.8 after you 0.08.
1.25.
Get that? And x is equal to what?
1.25.
1.25 feet. So to do that, you measure, I gotta find a different color. This is where your colored pencils come into play. I threw one in here. So if you're measuring from here to here, if you go 1.25 feet, 1.25 feet is 14. Okay? So now, and that's all that to figure out that spot.
Yep.
Okay? Now we want to figure out 13. You have a choice. You can either do from 14 to 13 or from 13 to 12.5. You just got to do the right distance from the right number you choose. So let's do the 13 to 12.5. So slope again is 0.08 is equal. So I'm going to circle that and put it there so that you guys remember. Then you have 0.08 is equal to 13 minus 12.5 is 0.05, or 0.5, sorry, divided by x. Okay. So then, when you start getting good, you're just going to go x is equal to 0.5 divided by 0.08, because you don't have to start crossing things off. It's always the same, but
6.25.
so x is equal to what?
6.25.
6.25 feet.
Yes.
So 6.25, which way are we measuring? Are we measuring from here, or are we measuring from 14 or from 12.5? 12.5. So 6 1/4. 6 1/4 is 13. All that for that spot. Okay?
Okay.
So let's figure out this one over here. So let's get 14 done. I always tend to get one whole number. I do a side, and then I pick a number, and I try to get that number done, then I try to get the next number done. Makes a little more sense that way. So you got 14. Let's figure out 14 on this side. So to figure out 14 on this side, we got 14.1. It's the same, similar math that's up here. The difference is the slope is different. So the slope is equal to 0.03. 0.1 divided by x times both sides by x.
You said 0.1? Isn't it 14 to 13.5?
What is that? It is 0.1.
Oh, because you're going from the 14, okay.
Yeah?
Yep.
Okay. So then it's 0.03x is equal to 0.1 times both sides by 0.03, or divide by both sides by 0.03, is x is equal to 0.1 divided by 0.03, which is equal to, anyone?
3.3 bar.
So what we're going to do is go 3.3. It's close. It's 14. So my contour goes this way for 14. Okay? So let's do 13. We know 13 is down here somewhere. So, oops, I'm going to do this. So let's get 13. The slope is 6%, so 0.06 is equal to rise. 13.5 minus 13 is 0.5 divided by x times both sides by x. 0.06x is equal to 0.5. Divide both sides by 0.06. X is equal to 0.5 divided by 0.06, which is, anybody?
8.3 bar.
8.35 feet. So 8.35, somewhere right about there, is 13. So now I can it's 13. Okay, next trick that I want to tell you about is every time you're putting in a contour line, you put the numbers in. You can put the numbers at the end, but the best place to actually put it is on the uphill side of the number. The reason why it's always on the uphill side and level with your contour line is that you can always know which way is down. Helps you keep track. It's actually a rule, believe it or not. Some people will do it this way. They will draw a line, put the 13 in and draw the line. That's fine, that's okay. I don't personally like it. I like putting it in a bow, because then that helps remember which way is up. Chelsea. Brain, what? Oh, yeah. Okay, so now we started to do this, and we just really jumped in with both feet. How scared are y'all?
I'm trembling in my shoes.
It's not hard, but it's not easy, right? And the thing is that you just have to think through the process. You always have one equation. And what you have to do is if you get two of those numbers, you can figure out the other one. You can figure out anything. And really, doing this is like a puzzle. you're going to be able to, by starting somewhere, you can figure out the rest of the site by kind of playing with it. And once you pick a number and go with it, if you're doing a proposed patio or stairs, once you pick a number, you can go with it and see if it works. And if it doesn't work, you can tweak it a little bit. It's not really hard. The best part about doing grades, in my opinion, is that you can always figure out if you're right. By going backwards, you can make sure that you have done all of your equations right. They always will work. Once you get started, it always works. So there is actually a right answer here. You might make up the starting point, so yours might be different than your neighbor's, but there's always a right answer once you get started. Yeah, that's math, right? Okay, so I think I'd like to do one more. Let's do 12. We'll get 12 in so that you get started. We'll do one more just to make sure everyone's on track. And then you can figure out 11 on your own time. By the way, guess what the first assignment is?
Oh.
Okay. We got 5, we got 1, 2, we got 9, let's see, 5 times 3, 15 spot elevations, you got to figure out the contours. And by the way, it's a little more complicated. Slightly. It's more fun this way, in my opinion. Okay, so there's nothing between here and here, but there is a 12 over here. So let's figure out 12 in this spot. So that's over here we have the slope. Oh yeah, I gotta pull this down again. We got the slope is 0.045 is equal to the rise, which let's go from this side 12.3. So let's go 0.3 over x. Times both sides by x. And divide both sides by 0.045. Oops. So 0.045, we get x, we get x over here, 0.3 divided by 0.045, which is equal to, anybody? Jason, quick on the buttons.
6.6 bar.
6.6
Bar.
Yeah.
Is that what you call it, bar?
No.
What do you call it?
Oh shoot. It's 6. Well, it goes 6.6666666, but it's not barred. It's repeating or infinity. So 6.6 feet. Which way do you measure? Do you measure from that spot or that spot?
Left spot.
Left spot. And the reason for that is because we did the 0.3. If we had come from here, it would have been 12. It would have been 0.6 from this direction. The slope is the same, but and so this is the way to check it. So let's do 6.6. 6.6. There's my spot. That's number 12. Check to make sure we're right, you can do that same equation but go from the other side. So it's still 0.045, but the difference is 12 to 11.4 is 0.6 divided by x. So x is equal to 0.6 divided by 0.045, which is equal to, it should be 20 minus 6.6, which is 13 point something. What is that? 13.3, yeah. Bars. I like that word, by the way. So if you go 13.3, it should come out to the exact same spot that you just did. Okay? That's your way of checking. Okay, so then we have the 12 over here. So So we got, I'll just do this one here, and we have a 12 in here. So let's do a couple different, let's do this one first. Because the best part is 12.3 to 11.7 and 12.3 to 11.7, it's the same equation. So 12 point,
It's the same slope, right?
same slope.
If it was different, then you'd have to do it twice.
You'd have to do it twice, but in this case, the slope is exactly the same. So slope is 0.03 is equal to, let's go 12.3, so it's 0.3 divided by x. Oops, let's get that up there. Divide both sides, or times both sides by x. 0.03x is equal to 0.3. And divide both sides by 0.03. So x is equal to 0.3 divided by 0.03, which is equal to
10.
10. I love that number. So, since we measured from 12.3, we're going to measure 10 from there. And then 12. And since this is the same slope with the same numbers, you can actually do 10 feet from here as well. And so your slope, right there. Yeah.
If you were doing this for whatever, a real life project, would the slope lines be computer generated or would hand drawn? Like would you plot your points?
Right. So there are computers that will do it, but computers tend to make straighter lines and not so soft lines. I like to hand draw because I like to make. Are any of the slopes out in the real world hard?
No.
No, they're pretty soft. And so there's a little kind of art to drawing contours. The only contours that are straight or hard are man-made. If you see on a set of plans a perfectly lined slope with no variation, you know it's man-made. If you see it perfectly distance apart, you know it's a road or a patio or something like that. It's easy to figure out man-made objects looking at it. And that's actually kind of true back, if you've done any of that kind of interesting the online archaeology, citizen archaeology. Have you ever seen or have you heard about it? You can look at photographs and you can scan the photographs and see if you see any archaeological back things left on the property. And most people are looking at the aerial photos. I actually bring in the grades on that as well because you can always see man-made grades as well. So that man-made grade might give you a clue that there might be something in there. Then you look at the historic aerial photos and see if it's been cut, if there's buildings, structures, or things like that. So they're finding more and more archaeological dig sites across the world because of the aerial photos, because everything has a satellite image over it, except for the presidential complexes. They seem to be blacking out for some reason. Okay. Is it, you get it?
Yep.
Get it? Okay. Okay. Let's see what else do I want to do. What's next? Okay, I think, let's see what time is it. I'll do one more, I'll do another bit here. And then we'll take a break, and then we'll do the last piece. way to do this is if you have a set of contours, you already receive them, but you want to know what the elevation is of that spot or maybe that spot. It's kind of the opposite. We're going to go backwards a little bit. So we're going to do this one the opposite direction. So let's do this one first. Let's call this one A. We'll call this one B. We'll do spot A first. The first thing that we got to do is we got to figure out the slope. And this is where we're all going to be slightly different. So what I tend to do, and so you're going to do your own math here, because you drew it differently than I drew it. But from those two lines, draw a pencil line through there. So the first thing that you want to do is you got to figure out the slope. You need to find the slope from here to here. Well, you know that this is a 1 foot contour. So slope is equal to rise, which is 1 foot, over run, and you're going to measure that. And for mine, I have 14 feet. So my slope, for me, and yours is going to be different, is 7.1%. Okay, but now I want to find A. So that's what I want to find. So what I'm going to do now is, now that I know my slope, it's 0.071 is equal to the distance is 6 feet over x. I don't know the run or the rise. So if I take that and times both sides by x, or by 6, x is equal to 0.426. Okay, but I want to know that spot. I know it's 0.426 of elevation change, and I measured it from the 15, so to find out that spot, it's 15 minus 0.426.
115?
Because I measured from this spot to get my 6 feet.
Okay.
Is equal to 14.574, so the real answer is 14.57 feet. But since I measured from here to here to get my 6 feet, I had to subtract. If I had measured from here to here, I would have added to 14. So there's a little trick to that. Guess which way you're going to go. Is it easier to add or subtract? Add. So guess which way I'm always going to go. I'm going to measure from the lower number up from here on out. But it's a good way to think about it. You do it differently one time, you'll learn a lesson. So, doing the spot B, I want to know what spot B is. First thing I need to do is figure out my slope. Slope is rise is 1 foot, run is 8 feet. So 0.5 or 12.5%. Okay, now I want to figure out the rise and run. So we have 0.125 is equal to, I'm going to measure from the 12 this time, so I'm going to measure from here to here, which is about 1.8 feet. About. So I'm going to go x over 1.8. I'm going to times both sides by 1.8. X is equal to 1.8 times 0.125. X is equal to 0.225. What I'm going to do, since I measured from the 12, it's 12 plus 0.225 is equal to the easy number. So my spot elevation here is 12.23. I tend not to go to 3 decimal points, 2 is plenty, and I always round up, use the rounding factors. We're never that accurate. By the way, 0.1 foot is a little more than an inch, because we're in tenths, not in inches. Okay. So 6 inches is 0.5. It's the difference between divided by 10 and divided by 12. There's a reason why most grades out there are done by engineering scales. It's a lot easier math than quarters of an inch and eighths of an inch and 16ths of an inch. The math is so much easier. So you probably will never get anything from me in architectural scale.
Hey Russ,
Yeah.
can you explain the 15 minus 0.426 again?
So I measured